Hello everyone, my name is Lok. I'm with VMware. Today I am going to present on the Cluster API vSphere provider. This is part 3 of a 3-part series. The first part I discussed Cluster API. The second part I talked about how do you build the management cluster OVA and then how do you deploy it. And as you recall, um, this is the UI console that is displayed when you deploy the OVA that we built in part 2 of this series. This is uh, our cluster API VM that was deployed from the OVA, and within that VM, it's running um, a Kubernetes cluster. And just to remind you guys, how did we get this screen? If you go back to the vSphere UI, and if you clicked on the VM and you clicked on Launch Remote Console, this is what comes up. So now let's go to our terminal. And if you've watched the second part of this series, um, you will recall that we deployed the OVA and then we also copied the kubeconfig from the cluster that's running inside that VM out. So if we look here, we have cluster API.kubeconfig. Next thing that we're going to do is go to the top level folder of this repo. Okay. I'm going to briefly discuss how to generate the example um, uh, cluster definition files for us to use, but I'm not going to actually execute it. I already built them already, so it's really easy. We have in our makefile we have some target. If you type in make pod YAML or make that dev YAML, it will generate a folder named out. So we go into out, and these are some of the files that were created from that make target. Um, why don't we do this? Why don't I demonstrate? Let's just go ahead and move out to out demo. And then why don't we create an out folder from scratch? So I've already set up some containers that we have stored in our registry that we're storing the builds for the vSphere provider. And these containers I've already built, I've built and tagged as KubeCon 2018 because those are the ones that we're going to use for the demo at KubeCon. And you can also use the same one. So if you type in use KubeCon equal to 1 and type in make, let me clear the screen here, make pod YAML. And let's go ahead and go into out and see. So these are the 4 files that it put on into this out folder. But if you're running this from the very first time, you will also get, it will also create some public private key pair for you to use for your cluster. So here it generated vSphere temp and vSphere temp.pub. Okay. So let's go ahead and take a look at some of these YAML files and explain what they are. So the first one that's probably one of the more important one is provider components. And in here, you see some custom resources that basically defines our cluster API API controller and necessary setup for the management cluster. And when this so basically, if you if you did like kube control create -f, then this will go ahead and deploy cluster API onto the cluster that you're talking against. But we're not going to use kubectl today. Okay, now let's take a look at cluster.yaml. In here, you will see that this is a definition of the cluster. We have two sections. The first section defines the network, and the second section defines the credentials for your vSphere cluster. Okay, so now we look at machine-side YAML. And here you will see that this defines a machine to deploy as part of the cluster. And here is here are some of the fields for the machine spec here. You can define the data center, data store, resource pool, network, etc. That you want to deploy onto, that you want the machine to be deployed to. You also have information like how many CPUs, how much memory, disk size, etc. I want to draw in, before I talk about that, so the other thing is this is the version of the Kubernetes control plane that you want to deploy. And what is the role of this machine? It's going to be a master. So I want to provide some context. The cluster.yaml and the machines.yaml file that I am going to deploy in this demo is the definition of the cluster for the target cluster. Now, if you listen to the first part of this series and the second part of this series, you would know that there are two clusters, right? There is the management cluster. Okay, in the OVA deployment, there's the management cluster, and then there's the target clusters. There's one management cluster that you deploy with the OVA, and using that management cluster, you can create many target clusters. Okay, and cluster.yaml and machines.yaml that I've been showing refers to a target cluster that we're going to deploy. Another thing I want to point out in this file is template. And what is this template? So this template refers to a cloud image VM template. Now, we already uploaded this earlier. I mentioned it in the second part of the series, and this is a VM template of a Ubuntu cloud image that I downloaded. If you go to the Cluster API vSphere provider repo, and you go into docs, into quick start, there is quite a bit of information on this VM template. But for now, I just wanted to refer to it, and let's now move forward. Okay. So we're going to get out of this folder that we just created, and we're going to go back into that demo that I built up earlier. And what I'm going to do is go ahead and take a look at the folder again. First thing I'm going to do is copy the kubeconfig from the management cluster that I downloaded earlier. Cluster API. Okay. So now I should have the file in this folder, and let's make sure that we can actually access that cluster. And indeed, we can access that cluster. So let's go ahead and get out of that folder into the main repo folder. And we're going to go to cmd cluster CTL. So cluster CTL is a CLI that was written to bootstrap cluster API. And this CLI is the tooling that we're going to use to interact with this management cluster today. So let's go ahead and go build it and go install it. Okay, and let's see if it, let's go ahead and take a look at the command line option. So today we're going to use the create command. Okay, so let's go back out into the main repo and go into out that demo. So cluster CTL, create cluster. Let's go ahead and take a look at the command line option. So we see here that there is a -E for an existing bootstrap cluster kubeconfig. And then we see here -C for cluster, -M for machine, -P for provider component, and then -- provider. Okay. So -E, give it the cluster API .kubeconfig. Now -P for provider components. Let's create a passing the cluster definition, the machine definition, and then we're going to specify provider. And provider in this case is vSphere. So if you recall from the first part of the series that the goal is to eventually have many infrastructure providers create their own providers, and eventually you should be able to use any provider from one management cluster. Okay, so go ahead and deploy this guy. Now, this is going to take a couple minutes, and if you don't want to watch this, you can come back, fast forward a couple minutes into the future, and then we'll continue with the demo. But for those who are still watching, I want to bring up the vSphere UI, and we can watch the cluster being created. And already we see here that this VM has been created under our kube resource pool. So it's cloning the cloud image right now, and then it's going to bootstrap the Kubernetes cluster on it. And then the last thing it's going to do is that it's going to deploy the cluster API controllers onto that cluster. So we go back. The machine has been created. Now it looks like it's not doing anything, but it's actually waiting for the cluster, the VM to boot up, and then the cluster to bootstrap. We will start seeing some progress shortly here. Okay, there we go. So right now it's bootstrapping the Kubernetes cluster on the target cluster. And you can see here it's looking for the kubeconfig, the admin kubeconfig for the target cluster. And I want to also mention that when cluster CTO finish provisioning this target cluster, it will automatically pull down the kubeconfig from the target cluster onto your current folder. And the name will be just be kubeconfig. And this is going to take a couple of minutes. Okay, we're back, and the cluster CTO just finished deploying the cluster. So if we now just take a look at the output a little bit. It says that that you can now access your cluster using kubectl kubeconfig. Now, what does if you recall, I mentioned that once this command has finished, it will automatically pull down the kubeconfig for the target cluster. So let's go ahead and take a look. So now we have cluster API.kubeconfig. This is the kubeconfig for our management cluster, and kubeconfig is the kubeconfig for the target cluster. So let's go ahead and take a look at this guy. So we're just going to use kubectl at this point. Okay, so we have a single master cluster, and let's take a look at all the pods that are running on this guy. And you see here, you see Cluster API Controller Manager, and you see the vSphere Provider Controller Manager. This is the vSphere provider, and this is the controller built from the main Cluster API repo. So we have a single master cluster right here. Now that doesn't seem very interesting. Why don't we create a couple of worker nodes? Okay. And I'm going to demonstrate something in this next part that that's a little bit different from the first part. So we're going to copy a file I created earlier. I have a lot of these out folders, so we're going to copy this file called machineset.yaml. Copy it into here. Let's take a look at what's in this machine set. So you'll notice in this machine set, we're defining a bunch of worker nodes, 2 worker nodes, and their role is going to be that of a regular node, and they're going to be running Kubernetes 1.11.3. And all this other information is very similar to the machines.yaml file that I talked about earlier. So I'm not going to talk about those right now. And this next part, instead of using cluster CTL, I'm just going to go ahead and use kubectl. Remember that the cluster API is now running on the target cluster, and we have the kubeconfig for the target cluster. So we can just do this. Okay, say create set.yaml, and it says it's created. Now, since we ran kubectl, it submitted the machine set, but it didn't actually wait for it to finish like cluster CTL would have. So we're just going to go ahead and monitor the creation of the worker nodes. And you can see right now that we have 2 worker nodes booting up test machine, and they're being cloned right now. And then once they're cloned, they're going to have to bootstrap and then join the cluster. So if we go back to here, we can monitor. We can also monitor the cluster by doing get node and then just doing a watch. Now this is going to take a couple minutes, so if you don't want to, you can just wait. You can just fast forward a couple minutes. It takes a couple minutes for the worker nodes to come up and get recognized. Okay, we just saw the first machine come up, and that's not the second machine, and it's still not ready. It's still going to take a couple more minutes. Um, while this is still running, I'm just going to go ahead and start talking, finishing up the talk, and hopefully by the end of this video, both nodes will be up and ready. Um, so if you were paying attention, you remember that we deployed the cluster API also to the target cluster. Um, this is the current state of the project. This is not guaranteed to be the way going forward, but the one advantage of deploying the cluster API to the target cluster is that you can because these controllers are running this reconciliation loop on the target cluster, you can actually do things like live edit the cluster, just like what I just showed, right? I deployed a machine set to the target cluster and it reconfigured itself. And if the controllers were not running on the target cluster, that would not be possible. So the other way that we can also uh, deploy um, the target cluster is to deploy the target cluster um, without the cluster API controllers running on that target cluster. Now, this is a term that we've been using um, around the office, and we've been calling this the vanilla cluster. So this is a cluster. This is a plain vanilla cluster that has no cluster API on it, has no ability to do any live management, live editing of the cluster, and we're not really sure yet which model we're going to go with yet. Maybe we end up supporting both model. Okay, so one of the nodes has come up. We're still waiting on the other one, but at this point, I don't think I want to wait for the other node to come up. And I think I'm going to end this video right here. Um, as always, we would love to hear from you. I want to bring you back to the GitHub page for our repo. This is our page. As you recall, the installer will build the OVA and you can deploy it. You can use all the steps that I showed in this three-part series and try it yourself. If you have any question, please go ahead and submit an issue, or you can contact me or other people on my team on the Kubernetes Slack. And yeah, we look forward to seeing you guys participate or trying this out. And one last thing is that I just want to repeat that we do have a KubeCon presentation, and this is the bi-weekly vSphere meeting notes. And I think in one of these meeting notes, I listed, yes, all the sessions at KubeCon 2018 that has anything to do with cluster API. And I want you to, there's about, I count 5 of them here. There's probably a lot more, but I want to draw your attention to this one. This is December 11, 3:40 to 4:15. That's Tuesday. And we're going to talk about a lot of things that was discussed in this three-part series. And perhaps you will see this demo again at that if you're going to KubeCon. Okay, with that, I am going to go ahead and end the demo, and I appreciate you guys all coming in and taking a look. Thanks. Bye.